So let's discuss exercise 1.5 third bit. Evaluate each of the following in terms of x and y. If it is given that x is equal to log 3 to the base 2 and y is equal to log 5 to the base 2. So if you consider the first one, log 15 to the base 2. So how to find, let us see here. Just 15 can be written as its product of primes, that is 3 into 5 to the base 2. So it can be expanded then using the formula log of mn to the base x is equal to log m to the base x plus log n to the base x. So in the same manner we can split this log 3 into 5 to the base 2 as log 3 to the base 2 plus log 5 to the base 2. But it is given that what is log 3 to the base x? Log 3 to the base 2, which is equal to as x, and log 5 to the base 2, which is equal to y. Therefore, it can be written as log 3 to the base 2 is equal to what can you substitute here? X plus log 5 to the base 2 can be substituted as y. It is the evaluation of the given problem, that is log 15 to the base 2. Log 7.5 to the base 2. It can be written as log 75 by 10 by removing the decimal point to the base 2. So here 75 can be written as 15 5s are 75 to the base 10 by 10 to the base 2. So we can cancel this 5 1s are 5 2s are. So it becomes log 15 by 2 to the base 2. So when it is in denominator, we can write it as log 15 to the base 2 minus log 2 to the base 2. As we know that law of logarithms, when the quotient rule is given, according to the quotient rule, log x by y to the base a or to the base n can be written as base a you can consider. So it can be written as log x to the base a minus log y to the base a. So according to this law of logarithms of quotient rule, we can split this one as is. So now it can be written as log 15 can be written as 3 into 5 to the base 2 minus log 2 to the base 2. So we can split it. Here log of 3 into 5 can be written as log 3 to the base 2 plus log 5 to the base 2 as a law of logarithms product rule. Here minus this value can be written as log x to the base x, which is equal to 1. Here this rule is log x into y to the base a can be written as log x to the base a plus log y to the base a. So this value can be written as 1, which is equal to, so log 3 to the base 2, it is given as x, log 5 to the base 2 is given as y minus 1. Log 60 to the base 2, whenever the value of x given as log 3 to the base 2 and log 5 to the base 2 is equal to y. So now see that first 60, write 60 as its prime factors, 2 30s, 2 15s, next 3 5s, next 5 1s. So 60 can be written as here 2 into 3 into 5, that is nothing but 2 square into 3 into 5. So we can apply that log 60 to the base as these values can be substituted in place of 60 here. So 2 square into 3 into 5 to the base 2. When we written as a product, now we can apply product rule, that is log 2 square to the base 2 plus log 3 to the base 2 plus log 5 to the base 2 based on the rule log x into y into z to the base a can be written as log x to the base a plus log y to the base a plus log z to the base a. Where there exist 3 terms, we are considered as x, y, z. If there exist only 2 terms, we consider up to x into y. So like that, the product can be extended in this way as log x to the base a plus log y to the base a plus log z to the base a. Similarly, we have written in place of x as 2 square, in place of y 3, in place of z as 5. So now we can write this as 2 into log 2 to the base 2 plus this value given as what? X here. X plus and log 5 to the base 2 can be substituted as y. So which is equal to 2 into log 2 to the base 2 value is 1 plus x plus y. So since here we can mention the reason as log x to the base x is equal to 1. So which is equal to 2 ones 2 plus x plus y. That's the final result of the log 60 to the base 2. Whenever you are going to express in terms of x and y, you will get these results. It is given that x is equal to log 3 to the base 2 and y is equal to log 5 to the base 2. Now we have to find its product of prime factors. Prime factors of 6750. See that as the units digit is end with 0, we can divide it by 2 according to the rule of 2. 2 3s are 6, 2 3s are 6, 1 left over, 2 7s are 14, 2 5s are 10. Next, as this digit end with 5, we can check it with 3 or 5 ones, 3 ones are 3 ones are 3 2s are 6, 3 5s are 15. Okay, next is the division rule of 3 applicable. Check it once as a sum of the digits. 1 plus 1 2, 4 plus 5 9. So we can divide once again with 3. 3 3s are 9, 2 left, 22 means 3 7s are 21, 3 5s are 15. Next, once again you can divide by 3. 3 1s are 3 2s are 6 and 15 left, 3 5s are 15. Now we can divide it by 5. 5 2s are 10, 5 5s are 25. Next, 5 5s are 25, 5 1s are 5. Therefore, logarithm of 6750 to the base 2 can be written as now log of this product of these prime factors. So here 2 how many times repeated? 1 time into 3 how many times repeated? 1 2 3. So 3 power 3. 5 how many times repeated? 1 2 3 and 5 power 3 to the base 2. Now we can expand this according to the product rule. What is the product rule? Log of x into y to any base is equal to log x plus log y to the same base a and a. So that is log 2 to the base 2 plus log 3 cube to the base 2 plus log 5 cube to the base 2. So here log 2 to the base 2 value, as we know that it is 1. So substitute as 1 or write as 1. So it can be written as first log x to the base x value as 1. Next, here we know that exponential rule, log x power m to the base a can be written as m log x to the base a. So what is the power here? 3. So 3 comes as product 3 into log 3 to the base 2 plus 3 log 5 to the base 2. So which is equal to 1 plus 3, and log 3 to base 2 is what? X, plus 3 into log 5 to the base 2 value is y. So which is the required solution? Is a very interesting expansion of logarithms. That is very simple problem is this. So it can be written as log 1000, which is equal to log 10 cube. As you know that 10 cube is equal to what? 1000. So here we can apply power rule. So log x power m to the base a, which is equal to m log x to the base a. So according to this, we can write it as 3 log 10. So if any base is not given, we can take its base as 10. So which is equal to 3 log 10 to the base 10 can be written as 1, since as you know that log x to the base x is equal to 1. So 3 ones 3. That's it. How to expand this given expression, that is log 128 to the base 128 by 625. So here 128, if you consider, find its prime factors. So what can we write here? 2 6 are 12, 2 4s are 8, 2 3s are 6, 2 2s are 4, 2 1s are 2, 2 6s are 12, 2 8s are 16, 2 4s are 8, 2 2s are 4, 2 1s are 2. So in the same manner, write the prime factors of 625 even. As the digit end with 5, we can divide this number with 5. 5 1s are 5, 5 2s are 10, 5 5s are 25. 5 2s are 10, 5 5s are 25. In the same manner, you can divide this 25 also by 5, by 5 5s are, next 5 1s are. So which is equal to logarithm of 2 power. How many times this 2 is repeated? Check in this as its a prime factors. 1, 2, 3, 4, 5, 6, 7. So 2 power 7 by logarithm of this 1, 2, 3, 4. 625 can be written as 5 power 4. So which is equal to, this is in the form of quotient rule. 2 power 7 by 5 power 4. So now you can apply quotient rule. 2 power 7 minus logarithm of 5 power 4. So which is equal to, so how, based on what condition we apply this, we written this. Let us write the formula here. Log of x by y, which is equal to log x minus log y. Next, this power becomes as what? Product. Based on the power rule, that is log of x power m to the base a is equal to m log x to the base a. So that we can write it as 7 log 2 minus 4 log 5. This is the expansion of the given logarithm. How to expand this given expression? Let us see here. That is log of x square can be written as x square plus log y power 3 plus log z power 4. So it can be also written as 2 can be written as 2 log x plus 3 log y plus 4 log z. Here what are the formulas we written in this? Let us observe this. Here we applied log x into y to the base a, which is equal to log x to the base a plus log y to the base a, which is nothing but product rule. According to the product rule, we can split this given expression as log x square plus log y cube plus log z power 4. Here the power rule is applied. What is the power rule we applied here? Log x power m to the base a. As power has come, this rule is known as power rule. So this power comes as a coefficient to the logarithm. So m log x to the base a. So it is the required expansion of the given logarithm of x square into y cube plus z cube. We have to expand the given logarithm. If you observe the logarithmic value here, there is the product of p and q, and at the same time there is a quotient term, that is r power 4. So here numerator is a denominator. So we need to apply product rule for numerator and division rule for this denominator. So for that, how to split? Let us see here. First let us apply quotient rule in order to write this one. P square q power 4 by r power 4, q power 3 by r power 4, which is equal to log p square into q power 3 minus log r power 4. Since as we know that log x by y, which is equal to log x minus log y. So now we can split this using product rule. What is the product rule? Log x into y, which is equal to log x plus log y. So according to the product rule, we can split this product, that is log p square plus log q power 3 minus log of r power 4. So now if you observe these terms, there is a power 2, power 3, power 4. So in order to write this as a product, so we should apply power rule, that is log x power m to the base a is equal to m log x to the base a. Now we can see this can be written as 2 log p plus 3 log q. Now this power becomes as what? Product minus 4 log r. So which is the required expansion of the given logarithm of p square into q power 3 by r power 4. Let us come to the last but not least of this bit. So logarithm of under root of x power 3 by y power 2. Now here as under root is there, whenever the root is given, every one will feel that how to solve, either difficult like that will feel, but actually it is also very important, easy. So we can convert this root into exponential form first. So logarithm of x power 3 by y power 2 whole power. So when root is converted into exponential, it becomes 1 by 2. Is it clear? Now, so this root converted as 1 by 2. Now 1 by 2 split into the brackets values, that is log of x power 3 into 1 by 2, nothing but 3 by 2, by y power 2 into 1 by 2, it can be written as y power 2 by 2. So this 1 by 2 splitting for numerator as well as denominator. So then it becomes logarithm of x power 3 by 2, and here 2 and 2 gets cancelled, then by y power 1, nothing but y. So now we can apply here logarithm of x power 3 by 2 minus logarithm of y, since we know that log of x by y, which is equal to log x minus log y according to the quotient rule. So here what is the power we have here? X power 3 by 2. So 3 by 2 can be written as 3 by 2 into log x minus log y. Here what is the rule we applied here? Log of x power m to the base a is equal to m log x to the base a. Right? Given that if x square plus y square is equal to 25xy, then what we need to prove here? 2 of log of x plus y is equal to 3 into log 3 plus log x plus log y. We need to prove this. So these type of problems will be repeats in the exam, so that you can mark it as important or keep a star mark for that. So how to prove this one? So in order to prove this, let us consider the given information, that is x square plus y square is equal to 25xy. So here square of x and y is there. So in order to apply x plus y whole square formula, we need to add 2xy on both sides. Adding 2xy on both sides. So then what will get here? X square plus y square plus 2xy, which is equal to 25xy plus 2xy. So now it is in the form of what? Expansion of x plus y whole square, that is x square plus y square plus 2xy. It can be written as x plus y whole square. In order to get its factors, we have added 2xy on both sides. So remember this. Now 25xy plus 2xy can be written as 27xy. Now you can take log on both sides. Taking log on both sides. So if you apply log on both sides, what do you get here? Logarithm of x plus y whole square, which is equal to log of 27xy. Now here it is the power rule you can apply, and here is the product rule. So what is the power rule if you apply here? It becomes 2 log of x plus y, which is equal to product rule if you apply here, that is log 27 plus log x plus log y. Based on these two conditions, that is log x power m to the base a is equal to m log x to the base a. Next, what is the product rule we applied here? That is log xy to the base a is equal to log x to the base a plus log y to the base a. So see that left hand side we got it, but what about the right hand side of the equation? See that we have log x and here also log x, log y and here also log y. But what is the required term here? 3 log 3. So that 27 can be converted into 3 log 3. How you can convert? Let us hear. What are the prime factors of 27 here? 3 9s are 27. 3 3s are 9. Next 3 1s are 3. So 27 can be written as 3 into 3 into 3, which is equal to 3 power 3. So now what can I write here? 27 in the sense log 3 power 3 plus log x plus log y. Now this can be written as 3 log 3 plus log x plus log y, which is the required RHS to the given LHS. So here LHS is 2 log x plus y is equal to, we got the required RHS as 3 log 3 plus log x plus log y. One more interesting and important problem we are going to discuss right now. That is, if log of x plus y by 3, which is equal to 1 by 2 of log x plus log y, then we need to find the value of x by y plus y by x. So let us mark it as some important one. So let us find the solution for that. Given that, what is the given information here? Log of x plus y by 3, which is equal to 1 by 2 of log x plus log y. So now denominator 2 if you transfer this side, what you get, let us see here. That is 2 when you transfer this side, it becomes 2 into log of x plus y by 3, which is equal to log x plus log y. So now we can write this product as power, that is log of x plus y by 3 whole power 2, which is equal to log x plus log y can be written as log into y, based on the condition log x plus log y, which is equal to log x into y. This is the reason. So now we can square is there. Before the square we can cancel the what? Logarithms. So then what does it become here? Log and log gets cancelled. So that what can write here? X plus y whole square by 3 square, which is equal to x into y. So expand this x plus y whole square. What does it become here? X square plus y square plus 2xy by 3 square value is 9, which is equal to x into y. Now this denominator 9 we can transfer this side, x square plus y square plus 2xy, which is equal to 9 times of xy. Now x square plus y square, which is equal to plus 2xy, if you transfer from left side to right side, it becomes minus, that is 9xy minus 2xy. So x square plus y square, which is equal to 7 times of xy. Then we can divide both sides by xy. X square by plus y square, which is equal to 7xy, is dividing by xy on both sides. So let us divide on both sides by x into y. So what does it become then? See here, x square by xy plus a y square by x into y, which is equal to 7x by xy. Here square and this x gets cancelled, square and this y gets cancelled, xy and xy is gets cancelled. Then what left over here? X by y plus y by x, which is equal to 7. It is the required solution what we require to prove. So that is x by y plus y by x, which is equal to its value what as 7. Given that if 2.3 whole power x is equal to 0.23 power y is equal to 1000, then find the value of 1 by x minus 1 by y. In this case, there are two equations, two comparisons. 2.3 whole power x compared with 1000, 0.23 whole power y also compared with 1000. So before going to be start the solution, let us write the given information, that is 2.3 whole power x is equal to 0.23 whole power y is equal to 1000. Okay, in this first comparison, that is 2.3 whole power x is equal to, what can you write here? 1000. That implies 2.3 whole power x is equal to 10 power 3. 1000 can be written as 10 power 3. So here this can be written as 2.3, which is equal to 10 power 3 by x. Let it be equation number 1. Just 2.3 written, its value as what? 10 power 3 by x. Now let us consider second one to the 1000, that is 0.23 whole power y is equal to 1000. 0.23 whole power y, which is equal to what? 1000. That implies 0.23 whole power y, which is equal to 1000 can be written as 10 power 3. That implies 0.23, which is equal to 10 power 3 by y. So it is equation number 2. But 0.23 can be written as, if decimal point moves one step towards right side, then what does become 2.3 by 10, right? We can write by multiplying and dividing by 10. When you multiply with 10, decimal point moves towards right side, then it becomes 2.3, and divide 10, it becomes 10. So 0.23 value, what is the 0.23 value here? 10 power 3 by y, which is equal to 2.3 value is 10 power 3 by x by 10. So according to the equation number 1 and 2, we can write 0.23 value as this. Next 2.3 value as 10 power 3 by x. Now this denominator 10, if you bring to the numerator, it becomes 10 power 3 by y is equal to 10 power 3 by x minus 1. As we know that a power x or a power m by a power n is equal to a power m minus n. Okay, so according to that we can write this as 3 by x minus 1. Now we can compare this. When bases are same, powers can be compared. That is 3 by y, which is equal to 3 by x minus 1. So you can transpose this 3 by y towards this and minus 1 towards this. Then what does it become here? So it becomes 3 by x minus 3 by y, which is equal to 1. Now let us take 3 as common. 1 by x minus 1 by y, which is equal to 1. So into 3 if you transfer towards RHS, so 1 by x minus 1 by y, which is equal to 1 by 3. That is the value of our required question, that is 1 by x minus 1 by y, which is equal to 1 by 3. Eighth problem, that is if 2 power x plus 1 is equal to 3 power 1 minus x, then find the value of x. Here what is given? 2 power x plus 1, which is equal to 3 power 1 minus x. Take log on both sides. What will get? Log of 2 power x plus 1, which is equal to log of 3 power 1 minus x. So here whenever power is there, we can write as product, that is x plus 1 of log 2, which is equal to 1 minus x of log 3. So now you can split this. So multiply this, x into log 2, that is x log 2 plus 1 into log 2, that is log 2, which is equal to 1 into log 3, that is log 3, minus x into log 3, that is x log 3. Here we need to determine the value of x so that x terms to be written left hand side as subject. So x log 2 minus value, when you transfer towards right side, it becomes plus, therefore it becomes x log 3, which is equal to this one you can shift this side and this one you have to transfer this side. So according that log 3 minus this plus value becomes what? Minus log 2. So here what are the terms common here? Here is the x, here is the x, which is common. So let us take common, that is x log 2 plus log 3, which is equal to log 3 minus log 2. So this into term we can transfer that side, then it becomes x is equal to log 3 minus log 2 by log 2 plus log 3. So here x is equal to, what can I write here? As the difference of two logarithms can be written as their division, that is log 3 by 2 by log 2 plus log 3 can be written as log 2 into 3. So in the next step we can write as a single term, that is logarithm of 3 by 2 by log 6. Irrational or irrational? Justify your answer. That is the question. First check it. Whether it is rational or irrational, we can't determine directly. So let us take log 2 as x, certain value x. So if any base is not given, so we can consider it as 10. Now convert this into the exponential form, from logarithm form to exponential form. So it becomes what? 10 power x is equal to 2. Right? Here 10 power x is equal to 2. 2 cannot be written as 10 power x for any value of x. Did you observe here? Logarithm value we converted into exponential. For what value of 2 power, if you consider, it becomes 10 power x. Whatever the value of x you consider here, if you write 10 power, does it become leads to 2 here? No. So that is the reason 2 cannot be written as 10 power x for any value of x. So that log 2 is an irrational. Log 100 to the base 10 is equal to x. Then convert into its exponential form. So that is 10 power x is equal to 100. Let us convert into exponential form. By converting into exponential form, then what does become here? 10 power x is equal to 10 square. 100 can be written as 10 square. As bases are same, powers can be compared. Therefore, x is equal to what does it become then? 2. 2 is what here? Rational number. Therefore, what is x we assumed here? Log 100 to the base 10. So, which is equal to what? 2. That is rational.